There we go.
Here, try here.
It's got it like right. Perfectly good enough. All right. There we go.
NDA can't talk. NDA can't talk about that. I want to tell you so fucking badly.
Okay, so take a check.
Oh, good. Now you're all here.
No, it's just the space
It's
bar.
massive NDAs in my head right now, and I want to fucking do both the things so bad, and I can't.
We're good. All right. We're good. Hi, everyone who's here for next talk. Other people. Garrett's class. You're all kind of part of the family, I guess. So, it's fine.
So, since you're all here for next hop, do you guys know who your faculty advisor is?
You are.
Yes, very good. Okay, good. You got that right. Just so you know, now, Al, you're the president now?
Yes.
You're the president. Andrew? Was it?
Yeah, Andrew.
Is it Andrew?
Yeah, Andrew, yeah.
You're not John's secretary, right?
Yeah.
VP.
You're treasurer. VP?
Web guy.
Who's treasurer?
I'm treasurer.
You're treasurer. You're the guy. So you're gonna bring me all the blue forms, right?
Yep.
Okay. All right. So yeah, I just want to introduce myself since I'm here. Also, I know you guys do a lot of workshops, so just make sure you're not giving them labs that for classes that they wouldn't do. Because last year we had a problem where people getting some of the labs ahead of time and they were distributing them.
Well,
So-
we're doing the IP. We're doing something from the IP workbook that I think
Okay.
people eventually recommend, but that's
Yeah.
not.
Yeah, some stuff's gonna be similar.
That's
I don't know if there's any way around
Yeah,
that.
there is overlap, but
Yeah, there's a little bit of overlap.
We're stealing from Cisco, not our IT.
That's even better. How many people here are would be interested in getting a Cisco certification?
More Cisco.
Have you thought about organizing? Maybe like no?
Cisco's kind of been. It's a long story, but basically the contact that we have for their sponsorship is I talked to Michelle, and apparently it's not the best contact, so I have to coordinate with her to find a better. There's a better.
It's not Jeff Kaiser, is it?
No, it's
Bruce?
Oh, what's her name? No, it's a woman. No, that's from SIG. Maybe Felicia something, I think.
Is it the same one that is always sending me emails about the people visiting during career week?
that might be Cisco Meraki.
No, you mean
No, this is a
someone
Cisco
from our
person.
team?
Not Cisco Meraki, there's Cisco.
No.
No?
Yeah, we don't have that. That's,
Well, maybe what you guys might want to think about is, this is just a suggestion, and Cisco doesn't even need to be involved in it. You guys just get into groups and maybe pick up get the Cisco certification guides, the books, and then, you get into groups and maybe one group covers chapters 1 through 3, another group picks up 4, 5, and 6, and and then, you guys could just talk about it. But does anybody here have a Cisco certification?
Expired.
So you would probably be ideal to be the leads, right? Because now you know what the exam's about. You can maybe talk about your approaches to studying for it. So that might be something you want to do. I'm just throwing out ideas, but I'll let you guys get to it. I'm not home.
we tried to kick Garrett out of this lab last week on accident, or I did at least, without realizing who it was. So that's why we moved our times around.
So,
Right.
with that being said, if you're here for Next Hub, please go to nexthub.network/sign-in and sign in.
And then just a side note, the IP lab we hand out for any of you who are freshmen, I would suggest keeping that or scanning that in or taking pictures or something, because it's highly likely that you'll be asked to complete it again at some point in your academic career. But
Alright, so you want to take
yeah. So I'm sure you saw the spammy emails I sent out. But we are changing things up a little bit in hopes to introduce more topics, because we used to only get in around 8 topics per year. That's not just per semester, per year. So we're going to try to teach you a networking concept and then a system administration concept each week. And the system administration topic won't rely on any networking knowledge, and vice versa. So we've geared everything towards people who haven't heard of any of the stuff contained in the labs going in. That being said, if you're a returning member, we do have an advanced lab for you to do that will involve some of the content or some of the ideas of the overall labs for the week. For instance, this week it would be setting up a complex topology in Ip Gns3 for the super advanced lab, but it's aside. And then we're also going to be doing now something the sponsors really like, or hopefully really like to see, is what you do in the club, how you do it, when you do it, and all that stuff. They like to see examples of your work. And so we want to provide that to them and hopefully get a little more money for that. So we're going to be, we put in a little bit of a bare bones tracking system right now. It lets you upload your completed work once you're done. If you want to, you don't have to, of course. Yeah, so we'll be showing that at the end, doing that at the end.
Yeah, basic idea of this is that we let sponsor actually know that you do the work in here, and hopefully you'll get a job out of it. So today we're going to be discussing networking, specifically the third layer IP, and we're going to go in depth in that. So,
Yeah, so IP addresses are actually just IP addresses are 4 decimal numbers that are actually each of those 4 decimal numbers are 8 binary bits.
And the binary, so the way the binary works is that, like a lot of things in computers, it hinges on 2 to the x. And so what that is 1, 2 to the first, that might be 2 to the 0, yeah, 2 to the 0, 1, 2, 3, 4, 5, 6, on and on, up to 128.
this is a
Right. And so an octet is a grouping of 8 bits. A bit is a 1 or a 0. 8 bits also makes a byte. A byte is the same thing as an octet. And so if you look up here, this would be an example of a, all the way on the left-hand column that says octet. That's an example of a binary number. And so the way you figure out what number that represents is broken down over here. You lay out 2 to the x, 1, 2, 4, 8, 16, 32, 64, 128. Line up the 1s and 0s, and then do the addition at the end. And so, yeah, does that kind of make sense to everyone?
yeah, so every octet is basically so every 4 octet is an IP address. If you want to look at it that way, and you do want to know this because when you divide networks into smaller networks, which is a collection of computers, you do need to divide it to have specific. Let's say you're in a company that has 3 departments, and every department is for a specific thing, like HR, accounting, and finance. Every department has its own network, and you do that by knowing this information, like dividing the network based on that. So,
Okay. So, escape that and then fill it in. You gotta make it full screen. Alright, so then we're just gonna fill in this to kind of show you how that works. So, 1,
yeah, this is going to be 1 since the first.
0, 1, 1, 0, 1, 0.
I'll play around with it on the weekend or
1.
Yeah.
And that is 128 plus 32 plus 16 plus 4 plus 1 and equals Oh, I should have done that. Somebody do that on a calculator. Go to the next one.
65.
Just go to the next one.
Oh, shoot. I think it's 91, but I'm not sure.
181.
181. There we go. Sounds right. 80. There we go.
Alright, same idea. You look for these and you just order them based on the number in there. So this is gonna be 0, 1, 1, 0, 1, 1, then 0, 1. And that's gonna be 64 plus 32 plus 8 plus 4 plus 1, which sums up to
109.
Yep.
109.
Here, I'm typing them in now.
Alright.
I guess, yeah.
Yeah.
So it
You-
follows the same basic idea. The way that you would go backwards, if you have the number that you have a number that's decimal, say 200, say 150, say 30. All you do is you take
What was your number?
any number below 255, because 255 is the highest number we can represent using these. So if you take any number below 255, the way you convert that into binary is you find the largest number here that you can subtract from it. So if we said 250, first we would take 250 minus 128. We would set that on the 1 bit.
192.
8. And that would leave us with 22, which would be 16 and 4 and 2. So up there at the top,
Those are all.
that's that idea basically. You subtract the biggest number that you can until you get to 0.
Yeah.
You'll always get to 0.
So
Give you something to look at, but they don't.
So an IP address is simply 4 numbers separated by a period. But of course, those 4 numbers can be broken down into their binary values, and that's an important part of networking, is taking those IP addresses and writing them out as binary, and then working with that. And so in an IP address, there's 2 parts of it. There's a network portion, and all that does is tell you what other computers you're allowed to talk to. So for 2 computers to be able to talk, they must have the exact same values for their network portion of their IP address. And that'll be the front of their IP address. That's all you need to know about that for now. And then the everything after the network part of their IP address is the host part. And that tells you exactly what computer is which within your network. So if you have 2 computers that can talk to each other, they might have the same beginning, 192.168, but then if they're on the same network, they'll need to have different endings so that you can know which computer is which.
Yeah, the network portion usually don't change, and the host portion varies depending on the computer.
And the way that we figure out what part of that IP address is the network and what part is the host is we look at the subnet.
Which is also called class.
You're right.
It's also called.
Class.
And he told the cops.
So
Got him with disorderly conduct.
there's a couple different classes of IP addresses, and you can tell what they are based on the subnet that is shown to you for that IP address, or based on the beginning numbers in that IP address. So Yeah, this won't mean much to you now, but as we keep going, it'll start to mean something more.
Okay. So for CIDR, it's just a different representation of the subnet, which is like basically slash and then a number. So if you have like slash 24, that means it's class C, and then you can look here, it's a class C, and it represents these these, this address, which is 255, 255, 255. If you remember back here, if you sum up all of this, it would be like if these from 128 to 1, they were all filled up as ones, it will be 255, which would be the subnet mask. And this goes for all three octets, and this is the host, or this is the network portion, and this is the host portion. So yeah, that's basically the CIDR.
And so the number on all the way on the left, that's how we write our subnets in decimal format, all the way on the left, and then you can see it converted out to binary right there. And so anywhere where there's a 1, that's going to be part of the network portion. And then
The zeros is the host portion.
right. And
So-
then
For the syslab or the system admin lab, we're gonna do something different. For the it's gonna be a lab that allows you to use a virtual machine basically, and then do stuff with it rather than using the physical machines. And this is just a way to introduce the Gns3 software.
so this will be, that lab is pretty much just looking at, it'll let you take these equipments that we have in the racks there, and it'll let you create them on your computer. So you can basically use those things that you would have to come here to use in the racks. You can use those just from any computer that you have access to this software on.
So it's basically as packet tracer, but more robust, I guess. Like it allows you to open virtual machines like PC or whatnot.
So that may have been a little bit of a kind of brief rundown on IPs. We tried to simplify it as much as possible, but the IP lab does a really nice job of summing up all the data. It gives you it all on one nice page, and it'll be really easy to see how things all fit together if that slideshow is a little bit spotty for you. Yeah.
Alright, with
That's
that,
about it.
if you have any question, feel free to ask, and you can go to nexthub / what is it, events?
Yeah.
/ events, and you'll find the labs.
Yeah.
And if you have any questions, just let us know.
So, nexthub.network, events tab, build at night. It's the first one. That's the Gns3 one. We have copies. There's a PDF of the IP lab up on the website, but we also have them printed out right here. Yeah. So, if anyone wants to come grab one of these, and then this one, you might want to do one, your own time, or do it after you finish the GNS3 lab, because the GNS3 lab is going to be easier to do on these machines here than potentially at home.
Yeah. And if you have any question about the packet, just drop us a question in Slack, and we'll be happy to answer.
Yeah. All right. Yeah. I'll put the let's put the link to the event up on the slide.